Okay, so far in chapter 5, what we've been talking about arithmetic operations with matrices. So we've talked about how to add them, subtract them, and multiply them or find the product. Now, what we're going to talk about is finding the inverse. Okay, so some things we learned that matrix multiplication is not commutative. Okay, since it's not commutative, that means we cannot discuss the division of matrices because that does not make sense. Okay, so instead we introduce this new idea called the inverse of a matrix. Okay, so the goal of this section is to learn how to compute the inverse of a matrix. So let's start there. So notation, the inverse of an n by n matrix. Notice that n by n means it's what kind of matrix? A square, good. It's a square matrix, okay? So the inverse of a square matrix A is denoted as A raised to the negative 1. So we read that as A inverse. We read that as A inverse, okay? The inverse of an n by n matrix A is the n by n matrix A inverse that, when multiplied by A on either side, yields the n by n identity matrix I. Okay? That is A times A inverse is equal to A inverse times A, which is the identity matrix. What does the identity n by n matrix look like? What does it look like? No, it's not a 1 by 1. Online they said a 1 by 1. It's not a 1 by 1 matrix. What does an n by n identity matrix look like? Yes.
1 0 0 1.
Not 1 0 0 0 1. That's what you said?
Like a 1 0 and then like a whatever the number is and then 0 1. Whatever.
But what you're saying to me, you're saying 1 0 0 1. What size is that matrix? What size? 2 by 2. I'm asking you, what does the n by n identity matrix look like? It's a square matrix with what? Use your terms. With what? Good, with ones down the main diagonal. That's what I heard online. So you have 1, 1, down to 1, then you have 0 everywhere else. So we can make this a little bit better. Let's erase this. So you'll have 1 0 0 out to 0, then you have 0 1 0 to 0 0 0 1, then you'd have 0 there out to 0, then you'd have ones along the main diagonal, zeros everywhere else. Okay? That's what the n by n identity matrix looks like. So another definition here is that if A has an inverse, it is said to be invertible. It's said to be invertible. Otherwise, it is said to be singular. So non-invertible is the same thing as singular. In any case, when you're talking about an inverse, you know your matrix has to be what kind of matrix? What? Well, that's going to be implied if your matrix has an inverse. But if you are talking about the inverse of a matrix, your original matrix has to be what kind of matrix?
Square.
A square matrix. It has to be a square matrix. Okay? So now what we're going to do is go through some examples. We're going to go through some examples. Example 1, we are going to determine whether or not the given pair of matrices are inverses of each other. If they are inverses of each other, what do we know? Based on what we just discussed on the previous page. What do we know? Yes? Well, not that they're just invertible, but in order to show that these two matrices are inverses of each other, what do you need to do? Very good. Online they said find the product. So you have to find the product. If you multiply A times B, you should get the identity 2 by 2 matrix. If you multiply B times A, you should also get the identity matrix. That's how we show if they're inverses of each other. Would you like a minute to try it? Okay, find the product. Okay, so let's find the product of A times B. So we have A times B. Oh no. A times B is equal to 2003 times 1/2 0, 1/2. So that's equal to the 1 position. We multiply the first row by the first column. So 2 times 1/2 is 1, plus 0 times 0 is 0. So you'll have 1 here. Then in the 1, 2 position, you multiply the first row times the second column. 2 times 0 is 0, plus 0 times 1/2 is 0. So you have 0 here. Then we have the second row, first column, so 0 times 1/2 is 0, plus 3 times 0, which is 0. We get what? 0. And then for the second row, second column, we get 0 times 0, which is 0, plus 3 times 1/2 gives us what? 3/2. So we get 3/2 here. Is this the identity matrix? No, which is not equal to the 2 by 2 identity matrix. So we can say, since A times B is not equal to the identity matrix, A and B are not inverses. They are not inverses. So remember, in order for A and B to be inverses of each other, recall we would need A times B would need to be the identity, and B times A would need to be the identity if they were inverses of each other. Okay? Okay? So, next example. Can A, which equals this 2 by 2 matrix, have an inverse? What do you think? I see you shaking your head no, Reed. Why? Very good. Very good. Because both of these entries here are 0, it's impossible for us to be able to get a 1 there. So no. So you are correct. So your answer is no, which is correct. It's not possible. So notice that both entries in row 2 are 0. So both entries of a product A times B will be 0. No, let's not combine the 0 and the no. Will be 0 no matter what B is. So in this case, we say A times B cannot be equal to the identity. And using our words that we learned on page 1, what can we say about A? Very good. Online, they said A is singular. So we would say A is singular. Good. What questions do you have? Okay, so now there's a formula for finding the inverse of a 2 by 2 matrix. There's a formula for finding an inverse of a 2 by 2 matrix. So let's talk about that. Did everyone get the information from the previous page? Okay, so the formula for the inverse of a 2 by 2 matrix is as follows. The inverse of a 2 by 2 matrix, like so, given with entries A, B, C, and D, this inverse is equal to 1 over AD minus BC times the 2 by 2 matrix with entries D, negative B, negative C, and A. Okay? So, we flip the entries on the main diagonal, and then we have the opposite of the entries off the diagonal, off the main diagonal. Okay? And we multiply that matrix by 1 over AD minus BC. This all makes sense as long as AD minus BC is not equal to 0, because we cannot divide by 0. Okay? If the quantity AD minus BC is equal to 0, then the matrix is singular or non-invertible. The quantity AD minus BC is called the determinant. That's called the determinant. And you need to make sure you are familiar with this. It's called the determinant of the matrix given here. Notation: the determinant of A is denoted as det A. This is the notation we use for determinant. You will see some people write this. They mean the same thing as the determinant of A, but I'll typically write this. Okay? So now, let's compute and find the inverse of the matrix if possible. Would you like to work the first one together? Okay, let's do that. So we're given the 2 by 2 matrix A equals 4 by row, 4, 1, 0, 2. Okay? Now, first things first, according to our formula up here, we need to take a look at the determinant, right? And to see if it's non-zero or if it's 0. Okay, so let's take a look at that. So AD, so the determinant of A, is equal to 4 times 2 minus 1 times 0. That's equal to 8 minus 0, which is 8. Well, that's good because it's not equal to 0, right? So that means that we can find the what? We can find the inverse. Good. So we have A inverse is equal to 1/8 times the 2 by 2 matrix with entries, what? By row? There are many of you online as well. Matthew is the only one that has been responding online. Go ahead.
2, 0,
2 what?
or 2, negative 1,
Mm-hmm.
4.
Good. Good. So you flipped the entries on the main diagonal, they became 2, 4, and then off the diagonal you took the opposite. So there you go. Good. So now we multiply each entry by 1/8. Remember, this is a scalar multiple. Multiply each entry by 1/8. So that gives us 2 over 8, which is 1/4. Then we have what? Negative 1/8, good. And then we have? And then 1/2, you got it. Good, so this is our final answer. This is A inverse. What questions do you have? Okay, go ahead and do B. Go ahead and do B. Determine, compute, or find the inverse of the matrix if possible. Feel free to discuss it with your neighbors if you like. Feel free to check in. Online, feel free to discuss it with each other. It's good discussion online. You get that for what? You got it. That's right. That's good. Okay. So what do you think here? You cannot find it, right? Because you have the determinant of A. I forgot to pause it. So you're going to have a whole section or minute or so where there's no talking. So you have the determinant of A is equal to 4 minus 4, which is 0, which means A is what? Good. A is singular. You got it. Very good. Okay? Now, okay, we know how to find the inverse of a 2 by 2 matrix. We have a formula for it. But what happens if the matrix is larger than a 2 by 2 matrix? There's a different process, okay? There's a different process. So let's do that one, okay? So how to find the inverse of an n by n matrix. Let A be an n by n matrix. To find A inverse, you take the following steps. First, write down the n by 2n matrix, A, adjoined with the identity matrix. All right, so you have A adjoined with the identity matrix. So that means you put your n by n matrix here, draw a line, then put your n by n identity matrix right beside it, okay? Where I is the n by n identity matrix. Then what you're going to do is row reduce this matrix with the goal of making the identity matrix on the left, and whatever matrix you're left with on the right, that's going to be the inverse. Okay? So it's just like an extended row reduction. You're putting an extra n by n matrix over here, which is the identity. You're going to row reduce the entire thing. And then you're going to end up with the identity on the left hand side of the block, and then you're going to have a matrix on the right hand side of it. Okay? So if row reduction does not result in the identity matrix on the left, then that means that your original matrix A is singular. Okay? So what we're going to do is we're going to apply this process or this method to a 2 by 2 matrix, although with the 2 by 2 matrix, you should use the formula, right? I'm just showing you with a smaller matrix first before we get into a larger matrix. Okay, I want to show you how it works here. So what we're going to do we're going to write down our n, so it says n by 2n matrix. So here, since n is what for us? What's n for our example 4? 2. We're going to have a 2 by what? 4. Very good. We're going to have a 2 by 4 matrix. So we're going to have 1, 2, and draw that line, 1, 0. And we're going to have 3, 4, 0, 1. Now, our goal is to create the identity matrix over here. To do that, we have a 1 in this position already, in the 1, 1 position. Now we need to create a 0 in the 2, 1 position. How do you create a 0? There. Your pivot would be this 1. How do you create a 0 there? Yes? Row 2 minus 3, row 1 to get a new row 2. Very good. Okay? Would you like a minute to write it out? Or you want to do it together? Together? Okay, so you would have row 2, which is 3 minus 3 times row 1. So you have 3 minus 3, that'll give us 0. Notice that row 1 isn't changing, so we're going to have 1, 2, 1, 0. Row 2 is changing. So now we're going to do 4 minus 3 times 2. 4 minus 6 is what? Negative 2. Good. Then we're going to have 0 minus 3 times 1. That's going to give us what? negative 3, good. And then we're going to have 1 minus 3 times 0, what's that? What is it? 1, good. Okay, so far so good. What we created is 1, what we've created is the 0 here. Now what we want to do is we can either use this as our pivot in row reduce, or you can leave it alone, or you can divide that row by 2. Which do you prefer? Or multiply the row by 1/2. Do you want to just use this pivot and then make this a 0? Okay, so let's just use this negative 2 as our pivot and make this a 0 here. So what's the operation? Row 1 plus row 2, very good, to get a new row 1, you got it. Row 1 plus row 2 to get a new row 1. So now we have 1 plus 0. Well, let's go ahead and write down row 2. It's not going to change. So we get 0, negative 2, draw a line, negative 3, 1. Okay? Now we have row 1 plus row 2. So 1 plus 0 is 1. 2 plus negative 2 is 0. 1 plus negative 3 is, what is it? Negative 2. Good. And then our last one is what? 1. You got it. Good. Now we need to do what? Multiply row 2 by negative 1/2. You got it. Very good. So you have negative 1/2 times row 2 to get a new row 2. So we have row 1 doesn't change, so you have 1, 0, and then you have negative 2, 1. Then what does row 2 become? And what? You said 3 over 2 and then 1/2? Negative half, good. Negative half. You got it. Okay? So we've row reduced and we got our matrix in this form. So what can we say? You did all of that to say what?
One on the right is the inverse?
Yes, this is our inverse right here. So we can say A inverse is equal to the 2 by 2 matrix negative 2, 1, 3/2, negative 1/2. That's the inverse of our matrix A. Now, remember, if it's a 2 by 2 matrix, use your formula. It makes your life easier. However, if the matrix is larger than a 2 by 2, then you use this process. Okay? So, of course, my next example is an example where the matrix is not a 2 by 2 matrix. Okay? So, we are going to, are there any questions, or what questions do you have first? None? Okay. So now what we want to do is find the inverse of this matrix A, which equals 1, has entries by row 1, 1, 1, 0, 1, 1, and 1, 0, 0. Okay? Here, we're going to find the inverse of our matrix using our process that we just learned, the method that we just learned. So we're going to take the 3 by 3 matrix. What's going to be the size of the matrix that we write down now? The adjoined matrix. 3 by 6, you got it. Good. So by row, it's going to be 1, 1, 1. Draw a line. 1, 0, 0. Then we're going to have what? You tell me.
0, 1, 1, 0, 0.
Good. Say it again. 0, 1, 0. Good. So can you talk a little bit louder in class? Because remember, I have this Bluetooth in my ear, and so I need you to speak a little bit louder. Okay? So what do we have for the third row?
1, 0, 0, 0, 0, 1.
You got it. Good. Okay? So now what we're going to do, what should be the first thing we try to do here? You've been doing row reducing for a while now. What should we try to do?
Bottom zero.
Create a zero where? In what position?
Row 3, column 1.
Very good. Row 3, column 1, you want to create a zero right here. Very good. So, how do we do that? What's your pivot?
Well, we can use the top.
So this one in the first row, first column. I'm trying to get you to use the first row, first column, or wherever you want, where the number's located, so you can tell me how to get there. Okay? So we're going to use the 1 in our first row, first column as our pivot, and then we're going to create a 0 in the 3, 1 position. Okay? So what's the operation that allows us to do that?
Row 3 minus row 1.
Good.
To get a new-
You got it. Row 3 minus row 1 to get a new row 3. So our first two rows do not change. We have 1, 1, 1. Draw a line. 1, 0, 0. Then we have 0, 1, 1, 0, 1, 0. And then we're doing row 3 minus row 1. So 1 minus 1 is, not everybody at once. 1 minus 1 is 0. Then we have 0 minus 1, negative 1. Then we have 0 minus 1, negative 1. Then we have 0 minus 1, negative 1. Continue. Let me know what we get. 1. You got it. Good. Okay. Now, what would you like to do? Row 1 minus row 2 to get a new row 1. So which one is your pivot? Entry 1, 1 is not your pivot. You're saying this is our pivot. What would be your pivot in that case? The 2, 2 position. Good. The 2, 2 position. This is the one you're using as your pivot because you said do row 1 minus row 2, right? So you said do row 1 minus row 2 to get a new row 1, which means you're using row 2 as your pivot. That's what that means. Okay, so this 1 is your pivot, so row 1 minus row 2. So the first row is going to become 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. Good. 0 minus 1, negative 1. And then 0 minus 0, 0. Row 2 isn't going to change. You have 0, 1, 1, 0, 1, 0. Row 3, what can you do to row 3?
Row 3 plus row 2.
Row 3 plus row 2 to get a new
Row 3.
row 3. Good. Whenever you do that, what do you get? You want a minute?
Sure.
It's row 3. Good. Is it possible, so what can we say from here? Say it again? We can say that A is singular. From this point, we can say A is singular because in this first in the left hand 3x3 block, you have a row of zeros, right? So we cannot row reduce or reduce the matrix to obtain a 3x3 identity matrix here. It's impossible. So we can say A is singular. And the reason is we have since the left hand 3x3 block has a row of zeros, we cannot reduce the matrix to obtain the three by three identity on the left. Okay? What questions do you have? Okay, so what you're going to do now is find the inverse that's a weird O of the matrix A, which equals by row -1, -4, 2, 1, 0, -1, 1, 1, -1. Find the inverse of that matrix. So remember, the way you start that out, you just take the matrix that you were given. So you would take -1, -4, 2, 1, 0, -1, and 1, 1, -1, and then you put this line, which means you would join the 3x3 identity matrix. So it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Does that make sense? What's the first thing we do here? Whoa. What's the first thing we do here? Yes?
Get rid of the ones in the first column, rows and inversion.
Good. Get rid of the ones or make these ones zeros. So did you use this as your pivot?
Yeah, I did R2 plus R1 here for R2.
So this -1 in the 1, 1 position is our pivot. And you said the operation was what?
R2 plus R1. And then I did them in the same step. I did R3 plus R1.
To get a new what?
R3.
R3, and then here a new R2. Good. So row 2 or row 1 is not going to change. So you have -1, -4, 2, 1, 0, 0. Then R2 plus R1, R2 plus R1. 1 plus -1 is? Not everybody at once. 1 plus -1 is? 0. Then you have 0 plus -4 is? -4. Then you have -1 plus 2 is? 1. Then you have 0 plus 1 is? 1. 1 plus 0 is? 1. Not with the highlighter, we can't write like that. Then we have 0 plus 0? 0. Good. Now row 3. Row 3, 1 plus -1? 0. Bless you. 1 plus -4 is? -3. Good. Then we have -1 plus 2? No, where am I at? Yes, I'm doing this right. -1 plus 2 is what? 1. 0 plus 1? 0 plus 0.
0.
And what's the last one? 1. Good. Now, what do you want to do? What's your pivot? What's your pivot now? So we use the negative 4 here as our pivot. We're going to make this negative 4 0.
Row 2 minus row 1.
Row 2 minus row 1 to get a new
Row
row 2. Is that what we're doing?
row. Oh, no.
Oh no, because we're changing which row?
Row 1. So
We're
row
changing
1.
row 1.
Row 1 minus row 2 again.
There you go. Row 2 is what our pivot. So we're starting out with row 1, subtracting row 2 to get a new row 1. Okay? So row 2 will not change. So we're going to have 0, negative 4, 1, 1, 1, 0. And then our row 1 is going to change. So we're going to have negative 1 minus 0 is what? What's negative 1? Good. Then we're going to have negative 4 minus a negative 4 gives us 0. Then we're going to have 2 minus 1 gives us 1. Good. And then we have 1 minus 1, 0. Then we have 0 minus 1, negative 1. It's a little sloppy. I'll make it a little bit better. So negative 1. Then we have 0 minus 0. What do we get? 0. Good. Now we want to create a 0 here. How do we create a 0 here using this as our pivot? Okay, so here we'll have negative 4 times row 3 minus, are we subtracting or adding? Plus, right? Plus 3 times row 2 to get a new row 3. So we have negative 4 times 0 plus 3 times 0 gives us what? What do we get? 0. Then we have negative 4 times negative 3 is? Talk, please. Negative 4 times negative 3 is? 12 plus 3 times negative 4 minus 12. So 12 minus 12 is? 0. Then we have negative 4 times 1 is negative 4 plus 3 times 1, which is 3. We get negative 4 plus 3 is? Negative 1. Then we have negative 4 plus 3 is? Are we together? We have negative 4 times 1 plus 3 times 1. What do we get? Negative 1. We have a sigh in the back. You tired? Okay. So we have what now? Negative 4 times 0 plus 3 times 1 is what? 3. Then we have, go ahead. Negative 4. All right. So there we go. Now what do you want to do?
Row 2, column 3.
Row 2, column 3 is a pivot? So you're saying use row 2, column 3. Use this one as your pivot? No, because,
That would be before, okay.
right, you want to create a 0 here and here now. So if you're going to create a 0 here and here, what needs to be your pivot? Go ahead. Row 3, column 3. Good. That needs to be your pivot. So our pivot is now this negative 1. And then we want to create zeros in the 1-3 position and the 2-3 position. How do we do that? Go ahead.
Row 1 plus row 3.
Row 1 plus row 3 to get a new row 1. Good. And
Also row 2 plus row 3.
you got it. Would you like a minute or you want to go ahead? Go? Oh. All right, let's go. So row 1 plus row 3. Row 1 plus row 3. Go for it. What do we have? And -4. Good. Now, with row 2, what do we have? We're adding row 2 plus row 3. You go.
0.
Good. Now, what do you want to do? Mm-hmm. And negative row 3 to get a new row 3. Good. You could have written that up higher and it could have all been aligned. But hey, let's go for it. Well, let me write this underneath. So I'll have enough room and won't have to make it smaller. So now using those row operations, row 1 becomes what? 1, -2, 4. Row 2 becomes what? 0, 1, 0. What's the right side? Good. And then the third row? Good. That's the identity matrix. A inverse. All of that to say, A inverse is the 3x3 matrix with entries 1, -2, 4, 0, -1, 1, and 1, -3, 4. Very good. So it takes some time. You have to be careful with your algebra. That's very important here. Okay? So now what we're going to do, we're going to talk about a fact and we're going to use this matrix for something else. Okay? So remember what we got. Now, note that you can use the inverse of a matrix to solve a system of n linear equations and n unknowns. Okay? So a fact here, if A is an invertible matrix, then the matrix equation AX equals B has the unique solution X equals A inverse times B. And this is true because what we do, so an aside, the reason that's true is because if you have AX equals B, and if you know A is an invertible matrix, then you can multiply by A inverse on the left, and that's a capital X here, not just little x. Okay, so equals A inverse times B. What's A inverse times A? What's A inverse times A? I. Good. It's I. So you have I times X equals A inverse B, or in other words, X would be equal to A inverse B. So that's how you get your unique solution. Okay? So you've been using, in your homework for 5.2, you've been solving things like AX equals B, and then 5.3 as well. So now what we're going to do, or yes, we're doing that here in 5.3, but you applied it in your homework, the AX equals B already. Okay, so now you're able to find X this way. So we are going to use, make this a little bit smaller. Use matrix inversion to solve the system of linear equations. So here, A is equal to this system of linear equations. Note A is just the coefficient matrix. Notice that I did not write down the augmented matrix. I just wrote down A. The augmented matrix would have 8, 3, 8 there. Okay? But this is not the augmented matrix. This is just the coefficient matrix here. Okay? So this column is X, Y, and Z. Then A inverse, which we just found the inverse of, is equal to this matrix. Okay? So what we have at this point, it says we need to solve the system of linear equations. To do that, we're going to use this fact right here. Well, we know A is invertible, right? So since it says if A is invertible, then the matrix has the unique solution here. A is invertible, so we know that X is equal to A inverse times B. B is just equal to the constants. It's equal to the column matrix that has the constants in it. Okay, so this means you have 1, -2, 4, 0, -1, 1, 1, -3, 4, and we're going to multiply that by the column matrix 8, 3, 8, and then what we get is going to be our solution. What's going to be the size of the resulting matrix? You said 2 by 3? You said just kidding, okay? What's the size of the inverse?
3 by
3 by 3. What's the size of this column matrix?
3. So 3 by 1.
So your result will be a 3 by 1. 3 by 3 times a 3 by 1 is a 3 by 1. So we're going to end up with a 3 by 1. So we multiply the first row by the first column. 1 plus 8, or 1 times 8 is 8, plus, I can just write it out. So we have 1 times 8 plus -2 times 3 plus 4 times 8. Then we're going to have, you tell me, come on.
1 times 3.
Nope.
No. 0 times 3.
0 times 3.
Plus -1 times 3.
Mm-hmm.
Plus 1 times 8.
Plus 1 times 8. Good. And then the last entry would be, how do we get that?
Wait, no, 0 times 8. Sorry.
That should be 0 times 8 up there. Good. Right? Because you have to multiply the first entry by the first entry here. So that would be 0 times 8, -1 times 3, and 1 times 8. Good correction. So then what's the last one? Online, you can contribute as well. Unmute your mics and talk. 1 times 8 plus. Mm-hmm. Plus what? 4 times 8. Good. So we end up with what? 8 minus 6 plus 32? 34. Good. Then we have 0 minus 3 plus 8. Good. And then we have 8 minus 9 plus 32. 31. Good. So this means okay, you may be listening to music online, but I can hear it too if your mic is unmuted. So you have X, Y, Z is equal to 34, 5, 31. Okay, that would be your solution. What would you get for your solution? So solve the system if B is equal to the column matrix 8, 3, 2. What would you get?
Equal 3, 4, comma,
Say it again?
It would be, everything's basically the same except for the Z with equal 4 instead.
No. Good. You get 10, -1, 7. Very good. That's what you get. Okay? Good job. So this concludes section 5.3 on matrix inversion.